It's Thursday, the 23rd of February. My name's Juan Brown. You're watching the Blanco Lirio channel, and the NTSB this morning just released a preliminary report on the Norfolk Southern Railway train derailment in East Palestine, Ohio. It answers a lot of questions about this derailment. Let's check it out. As we check out this B-roll video from the NTSB drone overhead view, we can see that the accordion shape of this derailment is indicative of an emergency brake application. That's why these cars are stacked up the way that they are. Remember, the train has two basic forms of braking. You have regenerative braking from the locomotive to help slow the train down at a reasonable rate, and then you have an emergency brake application where there's pneumatic brakes or air lines that run all through the train, all through all the cars, and it takes air pressure to keep those brakes off. If you lose air pressure, the brakes automatically, in emergency fashion, lock up. So it's apparent that when the one truck or wheel overheated it and started burning up and then began to derail, the airlines were separated, the air pressure was lost, and an emergency brake application was applied to this train as the engineer was trying to slow down the train from the defect detector warning that he received just prior to the derailment. Unfortunately, inside many of these tank cars was vinyl chloride, or the chemical used to make PVC or polyvinyl chloride piping, which heated up as a result of this derailment, began to burn, and emergency responders decided to do a controlled release or burn of the chemicals inside these tank cars in order to avoid a massive explosion. Okay, on to the report. On February 3rd, 2023, about 8:54 p.m. local time, the eastbound Norfolk Southern Railway General Merchandise Freight Train 32N derailed 38 rail cars on main track number 1 of the NS Fort Wayne line of the Keystone Division, East Palestine, Ohio. The derailed equipment included 11 tank cars carrying hazardous material that subsequently ignited, fueling fires that damaged an additional 12 non-derailed rail cars. First responders implemented a 1-mile evacuation zone surrounding the derailment site that affected up to 2,000 residents. There were no reported fatalities or injuries. At the time of the accident, visibility and conditions were dark and clear, and the weather was about 10 degrees Fahrenheit with no precipitation. Train 32N comprised of 2 head-end locomotives, 149 rail cars, so only a fraction of the number of total rail cars on this train actually derailed, and 1 distributed power locomotive located between rail cars 109 and 110. This included 20 placarded hazardous materials tank cars transporting combustible liquids, flammable liquids, and flammable gas, including vinyl chloride. Ball Note 2 explains that vinyl chloride is what's used to create PVC pipe. And when exposed to heat, vinyl chloride can undergo a rapid polymerization reaction, an exothermic chemical process which can pose an explosion hazard. That's why they did the burn-off, to prevent a massive explosion. Train 32N was traveling about 47 miles per hour at the time of the derailment, which is less than the maximum authorized timetable speed of 50 miles per hour for that section of the track. Train movements near the derailment site are authorized by cab signals and wayside signal indications with an overlaid positive train control system, and they're controlled by the NS Cleveland East train dispatcher located in Atlanta, Georgia. Positive train control is something the NTSB has been after the government for many, many years, and it apparently is in effect and operating during this derailment, and yet it failed to prevent the derailment. Train 32N was operating with a dynamic brake application as the train passed a Wayside defect detector. We'll get into details about these defect detectors in a minute here. On the east side of Palestine, Ohio at milepost 49.81. Now, dynamic braking is, as I described earlier, it's basically like regenerative braking on your electric cars. The Wayside defect detector or hot bearing detector, HBD, transmitted a critical audible alarm message instructing the crew to slow and stop the train to inspect a hot axle. The train engineer increased the dynamic brake application to further slow and stop the train. During this deceleration, an automatic emergency brake application initiated and train 32N came to a stop. So that's where the damage to the axle, wheels, or truck of the one car was so great that it ended up causing that car to either derail and or burn through the air lines. I suspect it derailed, pulling those air lines apart, losing air pressure, and causing the emergency application of the brakes and the rest of the derailment to be so catastrophic. Now here's some important information that answers a lot of questions about these detectors. Were the detectors working, and what did they detect? Let's go back and take a look at what these detectors are. Here on the Voyages of the Electric Car YouTube channel is, I believe, the actual defect detector in question here during this report. This gentleman goes out and takes a look at it. This is your hot box detector located right here on the side of the track. On the other side of this rail is an axle counter. That data goes into this box here and then goes into another box located on the side of the railroad to send a radio transmission report. Over here is some dragging equipment detectors, these flappy things, as if there's equipment dragging off of the train, it'll hit those flaps and break the circuit and send a signal about dragging equipment. And here you can see the hot box detector located on the rail, and this information is fed into this box here where a radio signal is automatically transmitted to the train engineer and a dispatch as to the status of the train as it crosses this defect detector.
CSX Equipment Defect Detector Milepost 700.1 No defects. No defects. Total axle 738. Train length 13764. Speed 45. End of transmission.
So it gives two reports, no defects, no defects. It gives you a report even if there is nothing wrong with the train as it goes by. And of course, the whole idea of this is cabooses have been gone for years. There's no firemen in a caboose anymore doing this job of monitoring the axles for problems, and so it's done automatically through this equipment. This gives a report whether there was a problem or not. No defects, no defects. All you railroad guys, straighten me out on this, but I believe that means no hot box and no dragging equipment if it's one of these combined units. It also gives you the total number of axles, so you can see if it's accurate or not, and then the total train length. If there is a defect, it'll tell you hot box and it'll tell you which axle is affected. When you get one of these positive indications, you need to stop the train and have it inspected. And these detection systems can detect any number of problems. Hot boxes where the bearings are getting too hot, acoustic bearing detectors, dragging equipment detectors, what we talked about, high car or shifted load detectors, wheel impact detectors, sliding or hot wheel detectors if the wheel's locked up and just sliding across the rail instead of rolling, vehicle imbalance detectors side to side and end to end. All kinds of different warning systems are available through these defect detectors. Now, these defect detectors are normally located every 10 to 20 miles along the route. And here's the important data on this initial report. On the Fort Wayne line of the Keystone Division, NS has equipped their rail networks with HBD or hot box detectors systems to assess the temperature conditions of wheel bearings while en route. The function of the hot box detector is to detect overheated bearings and provide audible real-time warnings to the train crews, like we just heard. Train 32N passed 3 HBD hotbox detection systems on its trip before the derailment. At milepost 79.9, The suspected bearing from the 23rd car had a recorded temperature of 38 degrees Fahrenheit above ambient temperature. Not very hot. When train 32N passed the next hotbox detector at milepost 69.01, so what's that, just 10 miles apart, the bearing's recorded temperature was 103 degrees Fahrenheit, rising but still not above the minimum threshold. The third hot box detector at milepost 49.81, which we may have been looking at in that previous video, that needs to be confirmed, recorded the suspect bearing's temperature at 253 degrees Fahrenheit above ambient. And I believe right about in here is where we got that security camera footage of that very hot box. It appeared like that whole truck was beginning to catch on fire. NS has established the following the railroad NS has established the following hotbox detector alarm thresholds above ambient temperature and criteria for the bearings. Between 170 degrees Fahrenheit and 200 degrees Fahrenheit warm bearings, non-critical, stop and inspect. A difference between bearings on the same axle greater than or equal to 115 degrees Fahrenheit, non-critical, stop and inspect. Greater than 200 degrees Fahrenheit critical, set out the rail car. So that means they'll stop the train, pull that rail car off of the train, get it on a siding, and send it into the shop to get it repaired. After the train stopped, the crew observed fire and smoke and notified the Cleveland East dispatcher of a possible derailment. With dispatcher authorization, the crew applied handbrakes to the two rail cars at the head of the train, uncoupled the head-end locomotives, and moved the locomotives about 1 mile from the uncoupled rail cars. Responders arrived at the derailment site and began response efforts. So no injuries. The crews were able to get the locomotives stopped. They didn't derail. They were able to get them uncoupled and moved away from the wreckage. On February 5th, responders mitigated the fire, but 5 derailed DOT 105 specification tank cars. Let's take a look at that. Here's your DOT tank car specifications and terms. DOT 105, a pressurized tank car that has additional safety features that's required by DOT 111 class non-pressurized tank cars. So it's a step up from the DOT 111. The DOT 105 specification tank cars, rail cars number 28 through 31 and 55, carrying 115,580 gallons of vinyl chloride, continued to concern authorities because the temperature inside one tank car was still rising. The increase in temperatures suggested that the vinyl chloride was undergoing a polymerization reaction, which could pose an explosion hazard. Responders scheduled a controlled venting of the 5 vinyl chloride tank cars to release and burn the vinyl chloride, expanded the evacuation zone to a 1 mile by 2 mile area, dug ditches to contain released vinyl chloride liquid while it vaporized and burned. The control venting began about 4:40 p.m. on February 6th, scratch the Friday part, and continued for several hours. While on the scene, the NTSB investigated and examined railroad equipment, track conditions, reviewed data from the signal system, Wayside defect detectors, local surveillance cameras, and the lead locomotive's event recorder. Just like an airplane, they have data recorders in these locomotives, and forward-facing and inward-facing image recorders, and completed interviews. NTSB investigators identified and examined the first rail car to derail, the 23rd rail car in the consist. Surveillance video from a local residence showed what appears to be a wheel bearing in the final stages of overheat failure moments before the derailment. The wheel bearing and affected wheel set have been collected as evidence and will be examined by the NTSB. The vinyl chloride tank car top fittings, including the relief valves, were also removed and examined by the NTSB, and the top fittings will be shipped to Texas for further examination. The NTSB investigation is ongoing. Future investigation activity will focus on the wheel set and bearing, tank car design, and derailment damage, a review of the accident response, including the venting and burning of the vinyl chloride, rail car design and maintenance procedures and practices. They'll also be reviewing the NS Railroad use of Wayside defect detectors, and railcar inspection practices. The NTSB is not involved with air monitoring, testing, or water quality. They're going to leave all that up to the EPA. Here's a list of some of the cars that were derailed, including all of the cars with hazardous material. Remember, it was car number 23 that the hot box was detected. This is the car suspected of starting the derailment when this truck on this car failed. As soon as that truck failed and began to derail, the emergency brakes were applied as the airlines were severed. So behind this car are here's the 11 hazardous cars, including which had the vinyl chloride in it. Isobutylene, butyl acrylics, stabilized, vinyl chloride, stabilized benzene, not good. And fortunately, the beer was saved, malt liquors, in cars 66 through 74. So this preliminary report from the NTSB answers a lot of questions. It explained how this train derailed so catastrophically with that emergency brake application once those airlines let go from that car 23 burned up set of trucks or axles. It also explains that, yes, the defect detectors were working, but the question I have is, are they calibrated correctly? And how could that bearing get so... Is it normal for that bearing to get that hot in a 20-mile distance? Did this engineer have any indication that the bearing was beginning to heat up before he got the final warning just prior to the derailment? Thanks so much for your support of this channel, especially the folks over on Patreon that make this content possible. We normally cover aviation accidents on this channel, but this is another NTSB report on a similar transportation accident, which has caused a lot of heartache and mess for the folks in East Palestine, Ohio. Thank you so much for your support. See you here.